welcome. Thank you for coming. So yeah, as was mentioned, my name is Baruch. Just to put a little bit of confusion aside, JFrog is a company. Artifactory is one of the products. We have 4 of them now, and I'll mention some of them during today's talk. I didn't come here to do a product pitch or to sell you Artifactory, so instead I will do something completely different. I will mention here and there a couple of our products, but that will not be the focus of this talk. Instead, we are going to talk about DevOps, which not only about tools, but about, of course, processes and people. So it will be a nice story about DevOps at scale, and the best way to present DevOps at scale from our perspective is a Greek tragedy. And that's for the obvious reason of, you know how Greek tragedy ends? Everybody dies, right? Everybody dies. So yeah, DevOps at scale, that's the obvious consequences. So this is why it is a Greek tragedy. So just an introduction. My name is Baruch. I'm developer advocate at JFrog, and at JBaruch on Twitter and all across the internet. I prepared a little page called the show notes. It's on jfrog.com/show notes. That's the only URL you need to remember out of today's talk. And there you will find the slides, which are already there. The video, I'm recording, so I will upload the video tonight or tomorrow morning. You will be able to pass it along. And all the links, all the terms, all the names, all the companies and products that I will mention, they're all there, so you can go there and do some more reading. A little raffle, just to say thank you for being here. You are not that many people, so your chances are very good. And just go there and fill a little form, and that's a nice prize. To start the conversation, the first thing I always ask in this kind of talk about DevOps is, what is DevOps? Right, so anyone has a misconception that they know what DevOps is? Yeah.
I guess, as a recruiter, when I talk to people, I guess I'd say a lot of people think that DevOps is more of, there's the two extremes where you can be a sysadmin in operations and you learn how to automate a process and now you're DevOps, or you're a developer who knows how to develop and you've worked in Linux, but you can't actually troubleshoot a Linux box, but you've done ops, so you're DevOps. The truest definition, I guess, I've come to work with managers and consultants is managing an actual coded infrastructure and developing a coded infrastructure and troubleshooting those issues.
Okay, and you call them DevOps engineers?
In that middle one,
Yeah.
That's what I've come to learn as what DevOps is.
Okay. No, but I mean the position, how do you call it? The people that you look for.
Oh,
how the position is called?
DevOps engineer, yeah.
DevOps engineer. We're going to talk about that. Yeah.
Yeah, to me, it's more like automating operations. Like you have a set of engineers who build the application, and then everything else is taken care of by the DevOps team, busy automating the operations.
So, who agrees that there is such a thing as DevOps engineer?
No, I don't, because everyone's definition is different.
No, but I mean,
I agree.
right?
Yeah.
Yeah, that sounds
Yeah.
reasonable. Okay. Well,
I thought it is a new job profile.
right. So DevOps engineers sound very cool, but by definition of DevOps, there is no such thing as DevOps engineer. And I will explain on VM diagram, of course. DevOps is this spot in the middle between development, operations, and QA, right? So generally, any engineer in your company becomes DevOps when they do all those things together, right? And one of the companies that known for a successful DevOps implementation is, for example, Netflix, right? So there is no DevOps engineer in Netflix. The engineer that writes code also takes it to production using the automation and all the tools that they have. right? So they are both dev engineers and op engineers in the same time. So there is no place for a DevOps engineer per se. That's the canonical definition of DevOps. We will see during this talk today that it might not always be the case. And we're going to talk about that. But mostly today we are going to talk about other view of the same triangle. And that's technology, process, and people, and all of them actually need to come together in a certain form or shape for DevOps to emerge, right? So we're going to take an example of an imaginary company called Pentagon Inc. They do credit card processing, and there are a lot of puns in the name, both similarity to other geometrical shape named companies that do credit card processing, and also a similarity to a certain government building in the shape of Pentagon and what's not. We're going to get to all of that. Right, so let's get started, and the first act that we're going to talk about is called Fire Brigade, and also known Reactive Ops, and you will see why the name when we're going to talk about that. And let's start by setting the stage. Remember, people, processes, tools. This is what we're going to talk about. People, 3 developers, 3 guys, 3 founders that come from on-prem background, probably defense, Pentagon, and they never did any cloud development, any SaaS, very like traditional development on-prem. They are smart people, they know their technology, a little bit hipsterish, and that kind of implies their stack, so they use a JavaScript and Node and Reactive and microservices and all the latest buzzwords. And the process, of course, for 3 people is minimalistic to non-existent for the obvious reasons. They have some Kanban or whatever process for managing the backlog, sticky notes, or maybe some primitive software. QA, again, as I mentioned, those guys are good. They understand the importance of test-driven development. So they have unit tests, integration tests, UI tests. Everything is automated, and everything is good. Well, for ops, they never did ops. They don't come from ops background, and they try to avoid it as much as possible. They went to a couple of cool conferences and heard a couple of nice buzzwords, and 2 of them they liked in particular, and that's serverless. Yay, no servers to maintain, and no ops. Yay, we don't need ops, right? And you will see in their selection of tools how it actually works, or supposed to work, and what's going on with that. Right, so as I mentioned, as the process is minimalistic, tools are minimalistic as well. So they use Jira for their backlog and the defects. Obviously, that can be any other tool for managing tickets. Even GitHub issues can work instead of Jira here, right? And they use GitHub or Bitbucket or any other cloud-based source code management. Travis CI, heard about Travis CI?
Jenkins.
Right, yeah, so Travis CI, you know Jenkins, right? Travis CI, think about it as CI server like Jenkins in the cloud, right? There are tons of them, Travis CI, Drone.io, CodeShip, Shippable, Circle CI, like a whole tons of CI servers in the cloud. And all of them do one thing. They monitor your source control, GitHub, Bitbucket, whatever you use. They check out the source from there. They build it according to your instructions or trying to guess according to the files you have in your source control. And then they deploy it to wherever you tell them to deploy. That's all. Very simple and works. And for the deployment, serverless, no ops. So a platform as a service, some kind of a runtime environment in which we can deploy code that will just run. Amazon Web Services Beanstalk is one of the examples. It can be Amazon Web Services Lambda, even a smaller environment, or it can be same tools or self-services in other cloud providers, and all of them have it. You have this platform as a service in Google Cloud Platform. You have it in Azure. You have it in even in Oracle Cloud. They are basically all more or less the same. So just one example can be any of those. And this is kind of minimalistic stack, and even as I mentioned, we can take the Jira out of picture, and it works for very early stages of a product. And once everything is automated, this is DevOps, right? We don't need DevOps engineers, we don't need Ops engineers at all. 3 developers, while they set up this minimalistic continuous integration and deployment pipeline, they literally do DevOps. This is all it takes. And let's see how it works for them. And of course, the first stage in this kind of scenario, when 3 guys wrote their startup, the first stage will be waiting, right? They have this product, they come, they do their product pitch, and they are waiting for their first customer. And let's say some fashion brand decided that those guys worth a shot, they're passionate, they give good support, and they want to give them a chance. So those guys have a first customer, and when they have the first customers, of course, they do the obvious thing, they drink, right? It's a huge party, their startup have the first major customer, so Friday night, everybody drunk, and they celebrate, and then around like, I don't know, like 3 a.m., there is a call from a customer. Nothing works. Well, now, of course, they do the obvious thing, they all panic, but then they kind of get themselves together, and they're going to fix the thing. And everything is very simple. There are 3 guys that have access to production. They built this production like a couple of months ago. They know everything what's going on, and they try to triage the problem, so they need to look at the logs. And where are the logs? It's a cloud platform, the logs are somewhere there, and then there are a lot of logs because it's microservices, and there are different types of services in different regions. So in one log, the exception is at 1 a.m., and the other, they see the same exception at 3 a.m., so they need to do this time zone acrobatics and try to somehow correlate them. And eventually they discover that Billy, one of the 3 founders, had a brilliant idea in the middle of their drinking party, and just went ahead, coded it, and committed the code. And once the code is committed, it goes to their CI server and then directly to production. And there was a bug there, and it wasn't cached by any test, and it took all the system down. Well, that happens, right? And the solution is very simple. All they need to do is kind of roll back this last commit, and then everything will work. But something strange happens. The code that was successfully built and deployed to production just half a day ago now suddenly won't build. What happened? How that can even be possible? So, does any of you remember the story of leftpad, npm gate, unpublished gate, all the same names for, oh, okay, so you're going to experience a wonderful discovery now that will definitely enrich your story luggage in IT, because that's a wonderful story. So a couple of years ago, I think it was already like 2 years ago, you know npm, right? Everybody know npm? It's a JavaScript engine that builds node applications, right? It's also a dependency manager, and they also have a central repository which is called npm registry. Okay? And npm registry is a huge repository. It contains all kinds of libraries, and one of them is, a couple of them of course are more popular than others. One of the popular ones called leftpad. Hence, as the name implies, leftpad pads text from the left. Pads a string with spaces from the left. apparently in JavaScript world you need a library for that, right? Not only you need a library for that, that library is extremely popular. Like every website or Node.js system in the world, directly or indirectly, transitively, relies on this leftpad. Now, the author of this library got in a fight with the maintainers of the NPM registry over name conflict, name dispute for another library of his. And then he decided to take his libraries and go away. So he unpublished all of his libraries from this central repository, from the NPM registry. And NPM works very weird in a way that when you build, not only NPM will check for new dependencies, it will also check for existing dependencies. And if the dependency that already exists in local cache but missing from a central registry, it will still fail the boot. So once leftpad was unpublished, every build in the world that depends on leftpad directly or indirectly was failing. And surprisingly great amount of websites were down. It was a disaster. And apparently those guys were the ones that used leftpad, and this is why they failed. Now, what you can do. First of all, you can write 12 lines of JavaScript code and pad your text from left. And this is what this library was, 12 lines of code. You can just write them. Or you can find some copy of leftpad somewhere. For example, you can build it from GitHub, right? Because it is in GitHub, and then put it as a dependency for your code. And well, those guys did one of those solutions, and eventually, of course, everything went back online. But of course, they wasted much more time than it should have taken. And the biggest problem is that those problems or similar problems kept hunting them for every couple of days, right? So a lot of sleepless nights, a lot of weekends not spent properly. And any of you been to this situation, to this mode of reactive ops or fire brigade, when all you do is putting fires down? I've been there, yep. Everyone who worked in a small startup actually experienced that, right? And that's okay, that's a phase that you need to live through. And then a second act emerges. When you grow bigger, you come to a second act which can be called smoke alarm installers or reactive improvement. Let's see what's new with our Pentagon Inc. in this phase. So they had a round of investment. So now they are 30 people. They hired 26 new developers, and one of them have ops background, right? It came from system administration or automation. 100 customers, they're growing, they get more customers, of course. Now they have a support team, just because waking up every night for responding to 100 customers, it's kind of painful. And the process evolves as well. So now they already can implement full Scrum, and they have enough people for that and enough scope of work. Who knows what exploratory testing is? Anyone? Well, okay. So there is a theory and there is a practice. In theory, exploratory testing is discovering new testing scenarios for automating them, right? So you, for example, click through your website, and then you record what you do, and you record the expected results for automating this process, right? Kind of writing the script for the automation tools like Selenium to actually automate. In practice, in a lot of companies that I heard this term, it's just a fancy name for manual QA. Manual QA is not very sexy. This one, sounds like a good job. So now they have manual QA, they have this guy that actually works through the system and record it and then try to automate it. And now we can start talking about ops. Right, there is a guy that can explain them that look, it's not all no ops and serverless. Even when you use SaaS systems, there is some procedures that we need to take care about. We need to know how we roll back. We need to aggregate the sources, we need, the logs. We need to analyze the logs, etc. So there is some concepts of ops going on there. And he actually teaches the rest of the team to become not only devs, but actually DevOps, right? So now look, there is this tool, it's called whatever it's called, and it does such and such, and now start using it, right? Another new role is the developer on call. So as we mentioned, they have support team, which are of course not as proficient in the source code and of course, the whole system as the developers that write this code. So one of the developers now carries the pager or the phone that the calls getting routed to, and that's the developer on call, of course. And of course, the logs and clocks, everything is now in the same time zone. So this is something that the ops guy actually teaches them, right? So we need to make sure that the logs are all in sync because we have microservices and we need them to be in sync, this kind of stuff. And of course, the tools start to evolve a little bit. So now they have support team and developer of call, which for sure means they need a knowledge base, right? Because in the middle of the night, they need to answer questions and they need a record of what's going on in the system. Confluence is one of the options. It can be everything. It can be, again, some wiki pages inside Jira in Markdown, for example, or it can be a proper wiki server or one of the wiki services that are there. Whatever makes sense, that's knowledge base is important. GitHub Travis CI, everything works. Of course, and now they learn that they need to cache their own dependencies and have a proper place for their artifacts. Caching dependencies actually allows reproducible builds. Storing the artifacts allows taking yesterday's build without even needing to build it, right? Because now they have all their artifacts. And of course, JFrog Artifactory is one of the solutions. Beanstalk is still fine. Some kind of log aggregator, Sumo Logic is one of the examples. There are tons of them on the market. Splunk, Logly, log entries, elk stack, and what's not. Like there are tons of them. We particularly love Sumo Logic, but probably everything works. And they aggregate the logs, they collect the logs, they have those collectors on each and every microsystem, and then they build like a whole one unified log which is searchable with regular expressions, patterns, query languages, and you can kind of parse it and see different statistics on the percentage of exceptions, etc., etc. Like a proper log analytics tool. Pingdom. Anyone heard about Pingdom? That's a very, very, very old service. And it does a very simple thing, one thing. You give it a URL, and it checks whether this URL is up and down. That's all it does. And that's a good start for those guys. At least now they are protected from this call from a customer, nothing works, or your system is down. That won't happen anymore, so that's a good step forward towards monitoring, although that's of course very basic monitoring. So let's see what happens now. So of course they had, if you remember, an investment round, so they drink. And Friday night, everybody's drunk, customer calls. Now it's not that your system is down or nothing works, because as you remember, they have protection against it. It's like something doesn't work. So let's say American Express transactions are failing. Visa and MasterCard are just fine, but American Express transactions fails. So the support guys and the developer of call, they of course do that first, but then they charge. And now they have a process, right? So the support guys consult with each other. No, we never heard about that. They check the knowledge base. It's not there. So they call the developer on call. And the developer on call goes like, yeah, well, I never touched the American Express part. It was Billy. Billy wrote the code. So we need to call Billy. Now, you already know what the problem with Billy is. Billy is wasted, of course. Billy is drunk. They kind of try to get him on the line. And Billy is like, yeah, I remember something like that. I think I saw this exception, but I also think I fixed it. So let's take a look at Jira. And in Jira, it's something strange. It's like close, or it's fixed but not closed, or not done. So it looks like I implemented it in code, but it never went to production. So yeah, let's fix it. And we're going to talk about the fix. Now, Monday morning, something new happens that didn't happen in Act 1. And that's the root cause analysis investigation. Everybody get into the room and try to have good and civilized conversation without blaming Billy too much about what actually happened. Well, he's one of the founders, so getting his respect. Now, what they do is building something like that. That's a root cause analysis report from an actual system that censored to protect the non-so-innocents. You can see how it's structured. So you see here all the metadata, where it happened, how long it took, right, when the report was completed, who are the team members that did the investigation, etc., all this fun. And then there is the content part. And the first is the record of the events. What happened when, right? So at 10 p.m., some process broke, something didn't work. And then 10:35, someone found some issues in the log. And then 14 past midnight, we started to verify that other parts of the system worked. And then at 3 a.m., something crashed in production and produced more errors. And then 3:30 a.m., those guys run really late this night, so they try to find what the problem is, etc. Now, all this record, it's not like, you know, a war room that everybody like sit in the same room and, you know, there are a bunch of coffee mugs and pizza trays. No, and someone sits in the corner and actually types what happened. No, it's all recorded, of course, from your Slack channels or HipChat or whatever you use for your communication. There is normally a channel will be opened for severity of that importance of an incident, and this is the log from their chat, from this chat. So that's really important to actually document in this chat whatever you do, right? So it won't be like, the system failed. Well, now it works. This is not very useful. Next part are the symptoms, and this goes into the knowledge base, right? It will appear in knowledge base if you see that, do this. And this is where the symptoms are important. What happened is a more technical description of what went wrong. So the last part, or previous to the last part, is the root case. And that should be very concise, one sentence, what actually went wrong. And in our example, this will be the queue of American Express transactions overflowed. This is what they discovered. So the symptoms will be American Express transaction failed with certain exception. The technical description will be how they are usually processed and what didn't work. And the root cause will be, well, we know that's because of the queue size. It was overflown and that's why. And then next steps should be something actionable that will prevent the same error from happening again. And that's just to remind you how this act is called, the smoke alarm installers. This is the installation of the smoke alarm in the same place where fire already occurred. We know how to prevent this one from happening again. And as I mentioned, in our example, it will be increase the queue size. So they go to Billy and they're like, Billy, how much we should increase the queue size? And Billy goes like, 42. Why? Well, because now it's 12 and it's a big buffer, so 42 should be fine. Right? Just because why not? So we're going to get back to this type of decision making later, and now I want to go back to talk about why root cause analysis is so important. So, and there are two obvious benefits. The first one is actually installing a smoke alarm in the place where a fire took place. So we know how to prevent those queues from overflowing. So we know for sure that that won't happen again. We have one problem less to take care of, but another, not least, but even sometimes more important side effect of root cause analysis is our relationships with our customers. The users and customers, it turns out, are extremely forgiving for problems that happen for the first time. Right? If there is a problem that happens in the first time, and you are very upfront with what happened, how you fixed it, and what you did to prevent it from happening again, probably, whatever magnitude of the problem it was, you will be forgiven. And here you might disagree with me and say, you know what, there are probably some problems of such magnitude that takes companies out of business. And I'll give you a story that proves otherwise. And that's another story from the real life. This time is from February this year, half a year ago. And that's the GitLab database incident. Someone remembers this shit show? Yep. So it was a lot of fun. Someone, they call them team member 1, deleted a production database. Well, that's okay. Who of us didn't ever delete a production database? That's not a big deal. The big deal started when they tried to recover. And that's an RCA report. That's exactly as you remember this log from their team of what they're doing, on how they try to recover. So first of all, of course, this is what happened, right? Team member 1 happened to run, and he rolled back 6 hours of database by mistake. What he actually did, he applied some script that reverted the database 6 hours earlier. This is what he did. This was the problem. And now they try to recover. Regular backups, no one knows where they are. When they find them, they are files with only few bytes in size. There are no backups. But that's okay, because they have SQL dumps. Well, the problem is that they performed these SQL dumps with incompatible tool to the version of the database that they used. The dump tool was 9.2 when the database was 9.6. And it turns that no SQL dumps were made at all. And it was like silently flat. They do have disk snapshots, but not for the database servers. They also have, of course, replication, but the replication procedure is super fragile, prone to error, relies on a handful of random shell scripts, and badly documented, which means they don't have replication. but they also back up to S3, but all the backups are empty. So out of 5 backup and replication techniques, no one actually worked. And they ended up with losing 6 hours of production customer data. And that's the worst that can happen to a SaaS company, losing customer data, right? This is like, my reaction to this, well, GitLab is going out of business. That's what I said. Not so fast. Thanks to this honest, transparent, and very detailed RCA process, they got tons of sympathy and love and respect. And you can see here, Je suis team member 1. Team member 1 is the guy that actually deleted the database, and they got some money from Google, and they got some cookies from CodeFresh, and it looks like they recovered completely. I don't know how many customers they lose, right? It's not public information, but it doesn't look like they're going out of business anytime soon. And now, half a year later, I don't know how many people remember this episode and will make decisions based on this episode. And so this RSA is very, very critical. By the way, this team member 1, he recently, a month ago, was promoted, or even before, just after the accident, maybe a couple of months after the accident. It was a scheduled promotion. The fact that he deleted the database didn't affect the decision to promote him at all. And the funny thing is his bio on Twitter: database removal specialist. He looks like a very nice guy. I'm happy that nothing bad happened to him. So yeah, so that's why RCA is so important. Act 3, and that's of course the tragedy culmination. This is where everybody dies. Call the perfect storm just because everybody dies. And again, let's see what changed now. This company gone through another stage. So they have one more round of investment. There are 100 engineers now, right? They have 5 developers with operations background and a whole performance engineer, like a whole human being. Chief architect joined. It's about time. It's a big company now. Customer success team. You remember we mentioned how useless the developer of call was in the last incident? Customer success team is a bunch of those developers on call gathered from different expertise parts of the whole system. They investigate the problems and they bring back to the development team what should be done. You build this team in a mixed way. First of all, there are people that actually love this job, right? It gives them the crime scene investigation feeling, especially when they forget that they are the murderers in the first place because they wrote it. And they love the thrills of the war room, of the pressure, of we need to take it, and there are people that actually love it. For the rest of them, you just force them. And you force them not because you are evil, but because pain is instructional, right? So all this process of getting better in fixing problems and then getting better of preventing the same problem from happening again comes from the same notion of pain is instructional. Why they decided they need to unify the logs? Because they were up at 3 a.m. trying to dig for this information in different parts of the log. Why they decided they need JFrog Artifactory? Because the lack of this system beat them before, and they suffered and they didn't manage to have a reproducible build. Pain is extremely instructional. And when you grow to a certain size, the majority of engineers usually are kind of protected from the pain. First, because you want them to concentrate on doing their job instead of putting the fires down, and now you have other people that can do it, but also just because the nature of your organization, right? The core development team are not on pager anymore. They don't interact, they don't deal with the support on a daily basis, so they stop feeling the pain, and that's a bad thing. So you kind of force them into this loop by rotating them on this customer success team and actually bringing them better to the support. And I can say from our experience from JFrog, we've been through both modes, right? So of course in the early stages when we were like 6 engineers, everybody were on call a lot, calls in the middle of the night, weekends and what's not, we all remember that, and this made our product better. It made our infrastructure better, it made our code better. Pain is instruction. And then we went to a certain stage when we were big enough, when they said, leave the developers alone, we want them to be productive, and we lost this feedback loop from what went wrong in the customer life when they use our product. And now, for a while now, we are looped back through those customer success team engagements when we have, again, answering the support calls and working with the support engineers to solve the problems. And now again, yes, we really should fix that because that's not the first time we see it. That's again on our plate and we actually can do it. So that's very important. Pain is instructional and it's not a bad thing. They have legal. It's about time. They're a big company, and if you remember, they do credit card processing, so that's finance. That's very sensitive stuff. CFO, they have serious investors that actually want to see where their money is spent. So they need to take better control of that as well. Reasonable client base, 1,000 customers. They are a good, successful company. Process evolves as well. Now, if 100 engineers work on a single project or on a single system, there is a real challenge of what development methodology can fix it, right? So they have like 8 Scrum teams, they work on a bunch of microservices, and that's natural and organic, but how do you blend them together? There are a number of attempts to supervise the Scrum teams with upper level of process. One of the more successful ones are the scalable agile framework, which is kind of an umbrella on top of agile teams that brings them together with one unified process. Take a look at that as well. As I mentioned, all the links are on the show notes to save as well. System testing, okay, they have like 40 microservices now. Someone have to take care of testing of the system in general. And here we are back to the ops team and to the DevOps engineers as a position that we discussed earlier, right? So if you remember what I said is that there are no DevOps engineers. Every engineer in the company is a DevOps engineer. And that's true except of those few people that enable DevOps for the rest of the company, right? Someone needs to write this infrastructure code. Someone needs to automate the processes, and someone needs to teach the rest of the organization how to work with it. Right? Someone needs to advocate for the DevOps processes. Once that's done, once we have the infrastructure and the people know how to use it and people want to use it, everybody do DevOps. Every engineer does DevOps. They run their code and they take it to production, and this is DevOps at its best. But someone needs to take care of the infrastructure, of the tooling, and of the education, and this is what DevOps engineer can do, or DevOps team inside their organization can do. Escalation path, that's another cultural thing. It always exists. right? Whether it's written or not, if there is a junior support engineer, they will pass the call to a senior support engineer, that will pass the call to this customer success team, and eventually to some developer that might be in charge, or a team member, etc. But having a written escalation path can actually be a very good thing to do, because in the tug of war of this, what's going on, knowing who you call next when you cannot manage actually helps. And sometimes the escalation path can go all the way to the CEO. And you might ask, why would you want to have a CEO in the end of this escalation path? And there are two answers. Sometimes CEO has work to do, usually just go and play golf with someone.
They'll turn back on now.
So that's actually CEO fixing the bug, right? Or the consequences of the bug. But there is another interesting aspect of that. When you know that in 8 hours you will have to call the CEO to report that some production system is down, and there is a mobile number, and it will be 3 a.m., and you need to wake up your CEO to break the bad news, somehow, magically, all the problems are solved in 7 hours. So that's another trick that usually works as well. Different regulations and compliances, SOC 2, what's the name? Scalable operation concerns, something, again, in the show notes. This regulatory act regulates how IT companies should manage to ensure data privacy and to ensure the security concerns of the company. And the reason why it is here, because for some people, some aspects of SOC 2 seem not seem in contradiction with the DevOps practices. For example, one of those that I struggled when I saw it for the first time, according to SOC 2, whoever writes the code is not allowed to deploy this code to production. And that's like the complete opposite of what DevOps teaches us. That you have the ownership, you build it, you own it, and you take it to the way to production.
The SOC or SOX? The SOX compliant.
I think it's SOC, maybe it's SOC.
Sarbanes-Oxley.
No, not Sarbanes-Oxley.
No.
This
Oh,
is
okay.
this is organizational, scalable organizational
Okay.
construct something. It's not Sarbanes-Oxley, it's something else.
Service organization.
Service organization constraints. Controls, thank you. This guy, right? And so we are, for example, in JFrog are SOC 2 compliant. And that's because our customers are, and we are, as a vendor, have to be as well. And so here, how do you deal with that? How do you deal with this? And a bunch of them are just boring. You need to change the passwords every 6 months. You need to have access directory in single sign-on. When someone is fired, you need to make sure that they don't have access. All this kind of stuff. So that's fine. But this problem on how do you do DevOps? How do you empower your developers to deploy to production when you have a regulation that says that they are not allowed to do this stuff? It turns out that if you have this DevOps team or Ops team that build the infrastructure for deploying to production, according to SOC 2, they are in charge of deploying to production. And they are different teams, they are different people, so it works nicely. Once they can guarantee that the process is robust and according to SOC 2, whoever writes on this process, the developers, are now just fine to deploy to production, right? So just remember that when you have something like that, it's usually been solved already by some nice bending of the regulation, or, you know what? For me, it's not a bending. It actually makes sense, right? The regulation says that it's important that two different organizations will take care of writing the code and deploying it, and if building the deployment pipeline is someone else's concern, that actually works. Okay, non-functional backlog is another stuff, and that's the chief architect brings a kind of a runway of what's going on forward and making sure that non-functional constraints like scalability and performance are actually part of the product as well. More tools, of course. Some external configuration management is now important, and that, of course, can be all the infrastructure as a service tools like Chef, Puppet, Ansible, and what's not. They take care of the configuration of the servers, of the pipeline, of the developer machines, make sure that here, the code here is auditable under SOX. That's exactly it, right? The code of the configuration management that the DevOps engineers, the DevOps team write, is different from the production code. It's different coded by other people, so it's fine. This is it, right? And of course, proper APM. It's about time to establish some proper monitoring of the systems, not only if it's up or down, but also performance-wise and subsystems monitoring, etc. By the way, Billy got promoted. He's now chief of R&D. And by the quality of the card, you can see that people not really like him. Okay, now let's see what's going on. So, as you remember, they raised more money. So what do?
Party.
Of course, they party. And you know what? Nothing bad happens on Friday night. And the weekend is just fine. But on Monday, remember they hired a legal? So apparently those folks have conferences of their own. And their company legal comes back to this conference and calls Billy. You know, Billy, I was in this legal conference and we discussed open source licenses. And I actually learned that was a fascinating topic. I loved it. The difference between AGPL and LGPL, crazy stuff, right? And so I learned that there are certain type of licenses that we cannot use. So can you tell me, dear Billy, do we have any dependencies with those licenses? And of course, Billy goes like, I have no idea, but I know who can find out. My developers. So he sends all his developers to go through all the dependencies and find licenses. Now the good thing is all their dependencies are already in one place. They use JFrog Artifactory, universal repository, whatever languages or technologies they use, all their dependencies are in one place, which is a good thing. The bad thing is they still need to go through all of them and try to find out the licenses. Sometimes they are in the descriptor files, maybe in POM files, maybe in package JSON files for NPM. Sometimes they are just zipped with an archive in terms of a license file. Sometimes they are in the file headers. Sometimes they're nowhere to be found. Sometimes there are more than one and they are conflicting. It's a nightmare. And of course, if they find this non-compatible license, they need to take this dependency of their system, find some kind of a replacement, and then write a lot of code to replace whatever they did with this dependency. Not fun. Well, done with that, and there is another problem. Now, remember the CFO? Now the CFO goes to Billy. Well, dear Billy, I would like to get your annual forecast for next year for operational expenses. How much we're going to pay to Amazon for our Beanstalk account? And Billy, of course, goes that. And then he's like, you know what, Lisa, I have the perfect answer for you. 42. Well, now, this is embarrassing. Billy has no idea. The good news are that if the company is successful and the sales are good, no one is going to take off the plug for production services if Billy was mistaken by 10 or 100 or doesn't really matter, right? But it's of course not very helpful situation to be, and that's a problem of its own. That is taken care of. Billy got another call, and this time from the head of sales. You know this guy? Oh, that's
Yeah.
Blendtech. It's a company that does blenders, like food blenders. And they have the most insane viral ad campaign in the world. So this guy, Tom, he blends things. He had a YouTube channel that is called Will It Blend? And he blends everything, like iPhones, iPads, like every gadget in the world. They try to blend it with their own blender, with of course the blended blender, and see if it blends. So that was another cultural reference for you to dig from the show notes. The question to Billy from the head of sales is: we have a very good prospect in the pipe, and it's a huge company, and they ask, will our system scale? Right? Let's say they have a logo of some fruit and they do some electronics, and now Black Friday coming out and people are going to buy their phones and maybe their laptops, and they want to see that our processing system can scale to the crazy amount of transactions they will have. And Billy naturally have no idea where this information can come from. From the developers, right? So he goes to his developers and say, well guys, I need to know if we will be able to scale to a certain amount of, I don't know, transactions per second. And those guys like, oh, sure, we wrote it, it's just fine. It will be just fine, don't worry. We will throw more hardware on it, it will be perfect. And how do they know? They have no idea, they just guess. And if you recognize the previous GIF, this one, it was from a great movie 300. And you remember how it ended? It didn't scale. They all did. So yeah, so that's it didn't scale, and it was kind of the tragedy, but we are here in California, and the story with a sad end is no go, so we will attach a happy ending to our Greek tragedy. And our happy ending is a smoky bear, a proactive improvement, and that's kind of a dream state that every organization should strive to get to in order to be able to do that proactive improvement. And it's all about process and tools, obviously. So process is stuff like performance and scalability testing. If they were doing that, they would need to answer whether they will scale or not. License and security management, again, right? If they were keeping track of their licenses and their security vulnerabilities, it won't happen. Proactive performance and threat reviews, they already have an APM solution. They need to start looking at the trends of whether some components is slowing down, whether there are some bottlenecks. How can we fix them? When we fix the bottleneck, where it actually moves, right? Because we never fix a bottleneck, we just move it to another location in the system. That's not funny, and that's a true story, and that's not an anecdote. This is how physics work. When you eliminate the bottleneck, some other place in the system becomes the bottleneck, right? It's just, this is how it works.
It's balancing.
Yeah, no, this is how it works. And something can be very wide, but still a bottleneck because everything else is wider. Non-functional definition of done, and that means that the performance, the stability, the license and security, and the performance trends are now part of the definition of done. You cannot release software without doing all that. And that's the big difference. Now, it's not reactive. It's not that someone will ask me and then I will go and see it. It's actually embedded in the process itself. There are tools that help us, right? So, for example, we can add tools to JFrog Artifactory like mission control, or what is going to be in some point of future JFrog Insight. This is not yet reflected on the slides because they are very, very fresh news. We acquired a company called CloudMunch. Anyone heard about CloudMunch? CloudMunch. So CloudMunch solves the problem of getting the information to the IT management. So this problem of, well, I'll look at it when I'll need it, or I will ask my developers, as you previously saw, completely breaks. And that makes sense that it breaks, right? So CloudMunch, they have a product which is called Insight, and it will become JFrog Insight, which collects information from all the rest of the systems and gives you kind of a dashboard view on what's going on, right? That's probably will be the next step of this day. X-Ray, JFrog X-Ray monitors licenses and security vulnerabilities. We'll talk about that. BlazeMeter, that's one of the tools that do performance testing. There are tons of them. BlazeMeter are very nice because they are in the cloud, which means they are infinitely scalable. Did anyone use JMeter or other similar tools? JMeter, right? So JMeter, how it works, you have your machine and you say, bombard this URL with this amount of concurrent requests and see what's going on. If there is a good request, measure the time. If they bounce, record that as well. That's basically JMeter. The problem is that you test this system from your machine, which by definition cannot reflect the scope of Black Friday sale for a popular brand, right? Now, BlazeMeter takes this JMeter to the cloud when you can actually scale this machine that you do the testing from infinitely. So you can simulate millions of customers approaching your website easily, right? That will cost you, but you can do it. And if you have millions of customers on Black Friday, money is not your problem, if you do everything right. So, right, so there are a bunch of tools like that as well. Service virtualization. Okay, now you have this testing and you are a credit card processing company and you have a stress test on BlazeMeter that will throw 1 million transactions on you now. What are you going to do? Even if you charge, like, if you go to the real Visa, MasterCard, and Amex and try to do something, they will charge you for that. So instead, service virtualization can simulate the services that you need in the outside world, and then you can actually test only your system. So these kind of tools actually are important for those performance trends that you need to find out. And a couple of examples of how it solves those problems. So how do we solve the problem of licenses? That's a screen for a JFrog X-Ray that can actually find the licenses. And you can see here that GPL was found, and the interesting part here is that it found on a jar file, which is a part of a WAR file, which is a part of some archive, which is inside a Debian package, which is inside a Docker layer, which is inside a Docker image. Most of those files are your custom files that normal scanning system will stop and say, well, this is a custom file, I don't know what to do with it, right? But X-Ray excels in that it can analyze all those files because of its universal nature and go further and further recursively all the way to the end of it to find licenses, security vulnerabilities. But you know what? Not only that, but whatever actually you care about. You can plug into X-Ray, for example, your APM system or your profiler, and then you can say, if you find a slow component in one areas of my system, do an impact analysis, and find whatever other components are impacted by this slow component and mark them as well, right? This kind of stuff because of this scanning capabilities. Now, how do we solve the problem of Billy that didn't know where the money goes? I'm going to show you a very advanced tool. So I don't know, I'm not sure that's for anybody. It's very financial heavy. It's called Microsoft Excel. This is the stupidest Excel pie chart ever that just maps what the team is working on. Engineering effort allocation. Some managers forced their developers to actually write down what they work on in Excel, and they have that. And when you thought that most of your effort allocation goes on big feature A, surprise, surprise, it's not. Most of it goes on keeping the lights on, which basically means fixing bugs, right? And the importance of this slide is not this table. The importance of it is that once you start monitoring, once you start pay attention to numbers, you have much more information, right? And you can do it with whatever tool you like. If you have good Jira system with time tracking, just make your developers fill the time that they spend on each and every task in Jira, right? That's simple. And it gives you numbers with some interesting insights. Here is another example from JFrog Mission Control that gives you some kind of view into estimated costs of your storage for artifacts in 3 months, in 6 months, in a year, and in 2 years, based on trends that you accumulated your artifacts previously. And of course, as I mentioned, stuff like JFrog Insight will bring all that into one dashboard that you can always see. And how do we solve the problem of knowing what is the quality of our software? Who knows the answer? How do we know what's the quality of our software? Except of asking the developers, which as we saw is not very reliable. How do we know?
Number of bugs.
Bugs! Thank you very much, of course. And how do we know about bugs?
Production issues. Right?
How do we know about them?
Monitoring,
Right
alerting.
now.
Monitoring, alerting.
Yeah, that's internal, okay, but how do we know?
Customers reporting.
Customer supporting, of course, right? Customer issues. So here's an example of customer issues for some quarter or in some year, grouped by severity. So you can see here that 65% of all the customer reports were severity 1 or severity 2. What do you say about the quality of this product? No, so-so. And here is, okay, so what's going on now? Now we get on this meeting with the head of the support and the head of the engineering, and the head of the support goes like, your system is crap. We have huge load on the support because of your bugs. Look at the amount of severity 1 and severity 2 that you have. Go ahead, fix them, raise the quality because we are dying here. We are working in triple shifts and it's horrible. Sounds legit, but it might very well not be true. Same tickets, now grouped by resolution. 90% ended up in fixing bugs. 52%, more than half, ending up in providing information to the support. The problem is not with the quality of the product, but with the training level of the support engineers. The same meeting between the head of engineering and the head of the support over the same product and over the same issues will have a completely different conversation with this information as well. Now, the conversation will be not your product is a piece of crap, fix it. But instead, we need to provide more education to our support engineers. Let's see how we do it. And that's again the importance of data. And this information is even easier to obtain because those are mandatory fields in your issues tracking system. All you need to do is make sure that your developers actually fill those fields, or the support engineers that close it, right? So information is the key, and that's what brings the company to, or the organization to this state of proactive improvement. Who knows what epimyth is? No one knows. That's okay. My wife, she has a degree in theater, so she knows, and that's the moral of the story. First, scale is a scale. You were listening to me for an hour, more than an hour now, and you were like, okay, we know what to do. We'll just go to this proactive improvement, and we will be in heaven, everything will be great. It cannot work that way. An organization should go through this scale for each and every step of it, and there is no fast forward. Proactive improvement is based on the pain is instructional, from the previous iterations. It brings a lot of process, and without proper justification, people hate a lot of process, right? So you start with a small amount of process, and when it turns out that it's not enough, you bring more. And when that's not enough, you bring in more, and only then when you have a process that people can justify for themselves, you have enough information to have this nirvana of proactive improvement. And of course, we're talking about change in all three of them. Change in technology, that's the easy part that we love. Change of people, hardest, we hate, and the process, again, when it's too much, everybody will resist it. So there is this process of introducing process. Two conceptual takeaways from this talk: the base of DevOps, you build it, you own it, and we spoke about that. And of course, pain is instructional. All this talk is about basically that. And that's all. Just to remind you, I'm at jbaruch on Twitter, jfrog.com/show notes, with the video tomorrow. The slides are already there, all the links. 3 last links in their list are to 3 books, which are very recommended to read. Release It. That's a book about continuous release, of course. The Phoenix Project, like absolute must for everyone who cares about DevOps, but also very fun book to read. It's fiction, so it's very easy. It's not like a technical book. And the last one, Scalable Systems something. The link is there. Feedback form, a raffle, as I mentioned, and thank you very much. So, questions? You just want to go home. Sounds good to me?
I have a question.
Sure.
So, in your presentation, you didn't talk anything about documentation that we need to provide in the process, you know?
Yeah, no, I think I mentioned the knowledge base,
Uh-huh.
and that's kind of the essence of it.
Okay.
It can be big or small, it better be big,
Mm.
right? And this is it, right? You use it for support, you use it for developers on call, you use it for onboarding new developers, and it's very important. It actually appears in our story very early. One of the changes in the toolchain of Act 2, when they are now more than 3 people that can sit in one room and talk with each other, is this knowledge base, which is of course very, very critical.
Okay.
And the X-ray, I mean, that is only, X-ray works on the Artifactory check.
Right. So X-ray rides on top of Artifactory and analyzes, or should I say, realizes the artifacts graph or the components graph that exists in Artifactory. Right? It sees the Docker image. Okay, let's see what's inside. Oh, inside we have a Debian package. That's not the end of it. Let's open the Debian package. There is a jar file inside, or war file inside. We know that the war file can contain additional jars. So let's take a step deeper, and then this graph is realized, and on top of this graph you can run impact analysis. Okay, so I found a jar file. Tell me all the Docker images that this file, jar file, exists in every level of it. Or you can run a scanning of new files. Every time new Docker image is added to Artifactory, we will crack it open and find everything what's inside.
Two questions. So one is the, for example, I mean, if the code is a C++ binary or something, right?
Yep.
Is there a way
So
to-
we go as deep as we can for the structure of the file. Right. Now, if it's just a binary file that we can know nothing about, we know nothing about. If it's a zip file with a bunch of JavaScript files inside, it also doesn't help. But if inside this zip file we will find Node.js dependency, we will know how to check it with external or
Yeah,
internal
exactly.
databases.
So based upon the file name or something, library name or something, right?
Yeah, no, we use checksums,
Okay.
and then we have converters to external systems.
Okay.
Right, so if we're
That's
talking
what I
about,
got from here.
right, so if we have external vulnerability system that work with names, we will map our checksums to the names that they understand.
Because some of the files are very obvious, right? I mean, when
Yeah, exactly.
you look at the file names, right?
Yeah, yeah.
So this X-ray just provides you information about the licensing information.
So we have a database that comes with X-ray,
Okay.
and it contains three types of information: licenses, security vulnerabilities, and versions. So for example, then you can say, okay, if I have a version older than 2 years, I want an alert about it, because it's some old crap that I probably need to replace. Or if I find a vulnerability in a version, but I know of the existence of another version that fixes this vulnerability, I want X-ray to suggest me this remediation, and it will do that. But you also can connect any external system to it, both for getting the information from it. If you have Black Duck, White Source, Aqua, and you're pleased with the quality of their information, you can say use your scanner and your information, but also their information because I want it, and because I already paid millions to Black Duck, and I don't want to lose it, right? And you can connect any information from the other side of it for the reporting. We have plugins that will be triggered when there is scan, or where something is found, or where the new remediation steps that can be made, and then you can script whatever actions you want. So for example, a scenario, we found a vulnerability, but there is a new version that fixed it. Replace automatically in my POM file, if it's Java, the old version with the new version. This is something that can be scripted inside X-ray plugins without any problem.
But then you have to do the whole build process again and go through the.
No, all we need for Artifactory and X-ray part to work is that your dependency will be in Artifactory, and then we know that it's fixed. Of course, you need then, in order to get it to production, you need all the CI and CD process to run, but that you done on a regular basis anyway.
Question. So first of all, great presentation.
Thank you.
Really like it.
Thanks.
Something that kind of resonated very well with me was that saying, you code it, you own it.
Right.
Now, I'm curious, in your experience, and the companies that you may have dealt with, how does that play out in practice, especially when the company has engineering organization that's beyond, let's say, 200 people?
So yeah, so there are number of issues here. First of all, the bigger the organization, the less agile or call it resilient or call it flexible it is, right? And usually the quality of people degrades as well, just because it's hard to have that many people and all of them will be the top of the line, right? And that of course makes everything hard in this organization, and especially the cultural changes that you need for DevOps, right? So of course it's very easy to do DevOps where you're 3 people. And of course it's very hard to do DevOps in an organization of 200 people, especially if yesterday they had those very convenient silos when they throw the code and the blame from over the wall, right? Of course it's hard. And the only 2 things that can help are, one you already know, pain, right? And the second is the feeling of accomplishment, right? So pain, obviously, when you take teams and you make them responsible and actually answering those 3 AM calls when the system goes down, they will change. Or they will go away. And both of them are fine, because if they're not willing to change, you probably didn't want them for the first place. And the feeling of accomplishment is the positive incentive, right? That was the negative incentive. The positive incentive is that you actually make sure that those teams that actually manage to do that get the credit. And you do it by small teams, because only by small teams you can articulate the change, you can articulate the shift in the mindset, right? You take those commander teams and you make them examples. First, you make them examples in pain, but then they are examples of accomplishments. And this is how it works. And if you read the Phoenix project that I recommended, it's exactly that story about a very low-tech and kind of old-school organization that, by a lot of pain, had this notion of small wins that help them move forward. There are no magic bullet. It's just negative incentives, positive incentives. We're very simple creatures in this regard.
And if I'm
The carrot and the stick.
And if I'm tracking you right, the idea is to make sure that the developers feel the pain of not doing proper job.
Exactly.
When it manifests in the operation side.
Now they cannot say, we done coding, it's not our problem anymore.
Right.
If it's not in production, if there is a bug in production, you are responsible. No one else. And the guys that used to deploy it now should help you to deploy it. They should automate the process so you will be able to deploy, and they should teach you how to do it, but you know it. It's not their job anymore. Yep. Thank you very much again for coming. Thank you very much.
Yeah, Drew, thank you. That was fantastic. That whole thing was awesome. I assume you've done this like 1,000 times because that was all pretty complex.
Yeah. Now that's one of my favorite and most successful presentations. So I did it maybe 15 times already, and I look for the next 50.
I work for Citrix.
Yeah.
Do it with not a question.
How about yourself?
Yeah.